Okay, YouTube, in this series of videos, this is my first one, we're going to get into inverse trig functions. And really, after watching this video, you should know more about what they are and kind of what they do for us, but also, really importantly, the relationship amongst their domain and range. And so, kind of the nice thing is that they are inverse functions, and so our domains and ranges, as we know, switch algebraically. So let's go ahead and start with that relationship here. Recall that with a function, we have this input-output type of relationship here. So I'm just going to kind of list these here, and I think that'd be a good idea. We say input, output, and we often refer to these as, of course, the domain and range. And so the thing we want to recognize here is that with this function, we usually use a letter F here. What we're doing with trig functions, and this would be like the sine, cosine, or say the tangent of the reciprocal functions, is we're often taking the sine, cosine, or tangent of an angle. And so these functions are really functions of angles. You give me an angle, sorry I got a little ahead of myself there. You give me an angle, I'll plug it into our function here, and I'll give you a trig value. And so what we're seeing here is that these input values, these are really, you guys, these are angles. And then we say that our outputs, what it's giving us is some f of theta, or I guess we would say value at that angle. And so what's going to happen is we're just going to kind of flip this relationship upon its head, and we're going to say, okay, well, what we want to do is define an inverse trig function here. We're going to call this f inverse. And I will be real honest with you. Let's make a list right now. We say inverse trig functions, We're going to make our list right now of what these are. But we say that these are sine inverse. We write it like this, sine inverse of x. We have cosine inverse of x. And we have tangent inverse of x. We're not going to worry about, I guess, inverse reciprocal functions right now. We're just going to worry about these three. And also, I want us to know this, and this is a matter of vocabulary, but you will see this written as arc sine of x, and you'll see this written as arc cos of x. Arc cosine is how you would say that. And you say this one is just arc tan of x, or arc tangent of x. And this is just another way of saying that these are inverse trig functions. But what happens is that we're going to be doing this. We're going to say, take this relationship amongst angle and then my function value at that angle, and we're going to flip it on its head. So what this means is our inverse trig functions here, what we're going to do is say inverse trig function, f inverse, we're going to plug our output values into it. We're going to say, oh, I'm going to go plug this into it, and say f of theta, this trig value here, and what we're going to get back to is the original angle. And so essentially, what we're going to see here is this, and I suppose we could write this another way. First, we say, well, first of all, let me get this up here for you. Let's think about f of theta. F of theta, right here, we say we have some theta, and this is an angle, and what we get is a value, okay? And so right underneath this, I'm going to write what we have right here, right above it, okay? Right there, another way. But what we're going to do with our inverse trig functions, we're going to say f inverse of some, not angle, we plug angles into our original function of some value, upside down A there. But if we had the value already, what this does for us is pretty cool, man. It gets us back to the angle. So in other words, if you know the trig value, what these inverse trig functions do is they give us an angle. And so I'm going to type this because my handwriting is rubbish, and I think I can type this a lot better. But we're going to write down really what these inverse trig functions are. And one thing we really want to know about this is that inverse trig functions, you can see this here, an angle is the same thing as what you get when you find an inverse trig function. So let's put this in, I guess it's going to have to be in green here, but inverse trig functions are, all caps here, oh yeah, are angles. That's what they represent. So I'm going to write it this way. It can be read as I am the angle for which this trig function, let me hit enter here, function has this value. And as I'm saying this, what I mean is, well, I'm going to have to write this one by hand, and that's fine. Let me get my pen tool back out here. It'll probably complain the first time. There we go. Okay, but when I say this little second bullet point right here, basically what I mean is when you say f inverse of, I keep wanting to write an angle, sorry, of a value, okay, and we get an angle here, really what we're saying is we would have, say, sine inverse of a value, or cosine inverse of a value, or tangent inverse of a value, and I suppose you could list any of those right there, but this is just an example. And really what this says is, hey, you know, sine, you took the sine of something and you got this. So what was the angle that gave you this? And so what we're going to talk about now, really importantly, is kind of this relationship amongst domain and range. And the easiest way to go about explaining the relationship amongst domain and range is probably graphically. And so one thing that I want to remember is that when you have inverse functions, and here's what I've done here, in Desmos here, I've gone from negative 4 pi to 4 pi on my x-axis. Looks like we're going by pi's. And on my y-axis here, we're going up, it looks like to, 2, 4, maybe this is 6 here. You know what, I'm going to change this. Let's go on our y-axis here. Let's go by 1 so we can see all the units. There we go. A little bit better. But we have sine and sine inverse, cosine and cosine inverse, tangent and tangent inverse. I just want to look at the relationship between their graphs. So when we hit our sine graph, we can see that this original sine function, going from 1 to negative 1 and 1 to negative 1, it has an amplitude of 1 and a period of 2 pi. And so when we look at its inverse function, let's remember something about inverse functions. Now what I just turned on was y equals x. And what we've seen before with inverse functions is the exact same thing that I suppose you see here is that the domain or range switch. You see, the thing here is with our inverse functions, we're plugging in the outputs of the original and we're getting the inputs of the original. So the things we plug in were the outputs of the original, and the things we get out were the inputs of the original. Then when you graph these, what happens is we get this reflection over this line y equals x. And so what I'm going to do is I'm going to click on this sine inverse of x, and you see it right here. It's this little blue sliver. And why a sliver? Why? So let's confront this right now. I guess the thing here is this. When you look at your original function, it passes the vertical line test. And so we say every angle went to one value. And so input goes to one output. This is 1 to 1. It's a function. When you look at the inverse function, well, we have this thing called the horizontal line test. And I'll even just put this on here right here. If I said like y equals half, we can see there are a lot of different angles that give us, a sine value of a half. Let's see if I can highlight some of these here. So look at this. The interesting thing is, basically, if this doesn't pass the horizontal line test now, if you were to reflect this whole graph over the line y equals x, you would have this thing that wraps around the y-axis like this, and it wouldn't pass the vertical line test. And so the important thing is this. We're essentially going to have to restrict the domains of all of our graphs here so that when we find the inverse, it's also a function. You can see that this blue graph right here would pass the vertical line test. And so what we do is this. With all of our trig functions, we do this. We select a really convenient interval of the graph to kind of pay attention to. And in this case, what I'm going to show you with our inverse sine graph is, because our regular sine graph hits all values from negative to 1 to 1 on an interval from negative pi halves to pi halves, then what we really say is we're just going to take this little snippet right here. And the neat thing is I can actually grab this. We say if I restrict my domain, I want it to be between negative pi halves is less than, let me go over here, is less than or equal to x is less than or equal to positive pi halves. So we say pi divided by 2. And so check this out. We see our original graph. Look at this. Our sine function way down has a value of negative 1 there, goes all the way up to a value of 1. And where it says negative 1.57, I want you to realize that's negative pi halves to pi halves. So we're kind of grabbing that interval, and when we reflect this over, check this out. The domain goes from negative 1 to 1. The domain, which was the range of the original graph here. And then the range goes from negative pi halves to pi halves. So really, truly, we've reflected over this line. And so essentially, the important bit here is this. With respect to our inverse function, look at the y value here. Remember what we're doing is we're plugging in, I guess, a trig value and saying, what was the angle that gave me this? And so the important bit here is this. The inverse trig function for sine is always going to tell you some angle between negative pi halves and pi halves that gives you that trig function value there. And so one thing that we want to make sure we draw in this note kind of video here in our module, we would say that we would want to draw this in. Our unit circle, this is a good way to remember it. But with sine inverse, essentially, what we're going to talk about here is its domain is negative 1 to 1. Good news is you don't have to graph any of these. You just need to look at the graphs to help you understand what it is that I'm saying now. But we would say that the outputs, remember the range is the outputs. These are angles right here, angles right here. And what I'm basically saying is with sine inverse, what's going to happen is pi halves is right here, negative pi halves is right here. What we're always going to get is it's going to tell us some angle between here and here that gave us some sine value that just happened to be somewhere between negative 1 and 1 here. So, if we said, sine, I'll just show you right here, sine inverse of positive a half. I would say, well, I know that on my unit circle, my y value here is a half. I know this. And so this would be 30 degrees, or we could say pi 6. But basically, we're saying, hey, what angle between negative pi halves and positive pi halves gives us this sine value right here, and I was able to find this one. If I had been asking sine inverse of negative a half, here's the thing, that's supposed to be a 1, you guys. If I had been asking this, I'd be saying, hey, I'm the angle that when you took the sine of me, you got negative a half. And I know that since there's a billion angles that do this, we're saying, but what angle between, negative pi halves and pi halves? And what you could see is essentially this here. It would just be the same angle, but down here in the fourth quadrant there. I don't know why that parenthesis didn't draw in. But basically, you could see that this would be a negative pi 6 or a negative 30 degrees. But basically, what you need to know is this. When you do an inverse sine function, it's always going to tell you an angle between negative pi halves and pi halves. Booyah. Okay, so now moving on to cosine and tangent. I'm going to make this so much quicker now that we've talked about sine. So we say, check it out. Here's our cosine graph. What interval of values am I going to grab? Well, I'm actually going to grab from an x value of 0 out to pi because, look, my function goes from 1 all the way to negative 1. I don't have to repeat after that. So when we turn on our inverse cosine graph, let me restrict this domain right here. We say this one's actually between 0 and pi. 0 is less than or equal to x is less than or equal to pi. And so check this out here. We have our cosine function. We just wanted to grab one small, really convenient section of the graph. We go from 0 to pi. But you could see that this goes from 1 down to negative 1 here. And if I were to grab the endpoints, I don't think it's going to let me do it here. Grab these endpoints here. I might be able to do it on this graph. We could see that these are just, switched domains and ranges. So again, the important bit here is this. Let me get this cosine graph out of the way. With respect to the outputs on cosine inverse, it's always going to be a value between 0 and pi, and that's what we want to write on our note sheet here. So, well, you just remember this kind of subsection of your unit circle. Let's draw this in here. With respect to cosine, and this is always true with cosine. Always true with cosine. Sine and sine and tangent will be similar, but cosine's the different one. Cosine, you can see this here, it's the same thing we've got written here, is always going to tell us an angle between 0 and pi. And then last but not least, here's what we're going to see with our inverse tangent graph here. Here's our tangent graph. It's got lots of little subsections. We say, well, what convenient section of this graph would I choose? Would I go between like pi halves and 3 pi halves, 3 pi halves and 5 pi halves? I think that the easiest would be around the origin. So we say between negative pi halves and pi halves, you'll see this, that when we reflect this, and let me restrict the domain here. This one's interesting. I suppose we want all x values between negative pi halves and pi halves. We say negative pi halves less than or equal to x is less than or equal to pi halves. And, ooh, this isn't good. Let me get some of this stuff out of the way. Pi divided by 2. It's this 2 right here. I think that we should be good there. Not really sure why that one's not showing up, but essentially we're grabbing between here and here. Maybe it doesn't like some, negative, that's what it is. There we go. We say negative pi halves to pi halves. You can see that this graph's reflected over. So the important bit here is this. With respect to our tangent inverse function, we're going to have, in terms of outputs, anything we want. This thing's going to go from negative infinity to positive infinity. No matter what, we're going to grab them all. But we'd say with respect to an angle, or actually not negative infinity to infinity, its domain is negative infinity to infinity. Its outputs, outputs. We're looking at the y values now. You see this negative 1.47 here. Basically, what I can tell you is if we were to go to the left, there is a limit to what that would approach, and it would approach negative 1.57. And what you're seeing there is that's the same thing as negative pi halves. Okay, so we have our domains and ranges switched here. But the important thing we want to sketch down is this. With respect to what an inverse trig function or an inverse tangent function will tell us. Let me scroll up a little bit here. Inverse tangent function. It's always going to tell us an angle between negative pi halves and pi halves. And I want you to notice something here. With respect to negative pi halves to pi halves, it never quite gets to negative pi halves to pi halves. And so what I'm going to draw in is very, very similar to what we drew for our inverse sine function here. Negative pi halves to pi halves. This is a positive pi halves, pardon me. But what I'm going to draw is this. Open dot, and it's always going to give us an angle between here and here, 0 to 0, negative 1, 0, 1. In terms of tangent function, and why do we put open dots here? Well, let's just remember one thing. When we take the tangent of an angle, we take our y value divided by our x value. And so we'd see here that at these angles, we have an undefined tangent function. And so basically, what we're going to get with an inverse tangent function is we're going to ask, hey, what was the angle that when we took the tangent of this function, we got, this value between negative 1 and 1, but not including those because, our tangent function never really quite gets there. It's undefined at those spots. So now, looking at these, what you're going to see is a similarity between sine and tangent. I just want to point this out. We got this half moon, but basically sine inverse and cosine, sine inverse and inverse will always tell us an angle between negative pi halves and pi halves. And cosine inverse is kind of the weird function here. It tells us an angle between 0 and pi. So you might be asking why this is. And what I'm just going to fill in here is this. We've seen this before. We say all students take calculus. But what you see here is this. For our cosine inverse values, we're going to hit all the positive values of cosine and negative values of cosine on this interval. So that's why we choose those. With respect to sine and tangent, we say all students take calculus. Students take calculus. We have all of our sine values would be positive up here and negative down here, and likewise with our tangent values here, we could hit all convenient tangent values where they're positive, and I guess that's not the S quadrant, it's the C quadrant, but we'd have positive and negative down here. And so what we're going to do, this last part of this video that is very long, I apologize, but now that we've gotten in the nitty-gritty, just kind of what the point is when we're doing this here. And so when we say, let's say arc sine of negative 1/2, what we're really saying is this. I want to know what angle was this that gave me a sine value of negative 1/2. And what I remember is this, with respect to sine, it is very, very going to give us outputs between negative pi halves and pi halves. So I'm just going to kind of put this sketch here. We say pi halves and negative pi halves. What angle gave us a sine that came out to be a negative 1/2? And the very first thing I can tell you is this. Sine is only negative down here in the fourth quadrant when you're only considering these two quadrants. And so I would say, well, you know, what angle would give us a sine of 1/2 in the first place? Now, if you're savvy with this, you already know on your unit circle that sine is 1/2 at 30 degrees here, or pi 6. And so what I can tell you is sine would be negative 1/2 down here in the fourth quadrant, and we would just say this is the same angle, but it's negative 30 degrees, and we want in radians here, negative pi 6. Now, I did that pretty quickly, and I'll tell you, I did that because I know my unit circle very well. If you had a unit circle handy like dun, 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 I know I've got one right here. I know I do. Let me flip back over here. Essentially, what you've got next to you is this tool that's going to say, now, considering an inverse trig function, I have some sine value that was between negative 1 and 1. You know, here's all our y values here. We're saying which one of these gave us a sine value of a negative 1/2 between here and here. And it's like, well, totally bingo right here. The funny thing is, though, on the unit circle it says 11 pi 6. And the funny thing there also is 11 pi 6 is like way outside of this range of values that we said we were allowed to be in. Our angle can only be an angle between negative pi halves and pi halves. And so what we have to do is modify our answer. And we basically just say, hey, you know, negative pi 6, you know, negative pi 6. And it makes it that easy. So it's kind of like saying, you know, it would have been the same as a 30 degree except for negative. Whoops, we need to go over one more slide. So really, the answer here is that the angle would have to be a pi 6 radian angle. So we say booyah grandma right there, or negative 30 degrees. And we'd say, we don't want this one here, sorry, we wanted the negative. So looking at sine inverse of negative root 3 over 2, we say sine inverse of negative root 3 over 2. We're saying what angle were you that gave you a root 3 over 2 negative? I'll flip back over to our unit circle here. We can see that of all of our y values between here and here, we get a negative root 3 over 2 down here. And so we'd say, what angle is this? Remember that it's got to be a negative angle. But we can see that this would be like a negative 60 degree angle here, or, you know, negative pi thirds. So let's see if I can get my slide right here. Nope, too far. We'll go to this guy here. Maybe this guy here. But we'd say that this is a negative 60 degree angle that did this, or we could say a negative pi third radian measurement. Now, sine inverse of 2, this is one of my faves, because sine inverse of 2, when does sine ever equal 2? I mean, think about what the radius of our unit circle here is in the first place. Sine gets up to 1, it gets down to negative 1. So when I ask you what angle, just pick an angle on here, any angle you want, where the y value on your unit circle would be 2. It'd be like, well, it's kind of impossible. So what this means is that sine inverse of 2 doesn't exist. It is not a defined thing. And so we'd say this does not exist as a value. So these last three here, we say r cosine of root 2 over 2. You know, when you think about the inverse cosine being root 2 over 2, this one's a little bit different. And, you know, here's the sketch we're imagining in our head this time. We're saying, what angle between pi and 0 with respect to r cosine? We say, well, where, first of all, would we have a positive root 2 over 2 when we're considering cosine? We'd say this would be some angle in the first quadrant. And if you know your unit circle well enough, you know that, you know, root 2 over 2 occurs at this 45 degree reference angle. And so we'd say that this would just be a positive 45 degrees, or pi fourth. When we look at the inverse cosine of a negative 1, we'd say, okay, well, you know, what angle, sorry to switch colors on you all the time here, but we'd say between 0 and pi gives us a cosine value of negative 1. And also, if you're good with your unit circle, you know that negative 1, 0 is this point over here. We'd say, well, then it must have been the angle pi that did this here. So it's got to be pi, or we could say 180 degrees that does this. And then last but not least, we say tan inverse of a -1. Okay, so interesting, tan inverse of a -1. One thing that you might want to know about your tangent values, and this is, if I go back over to the unit circle, is this. We say that tangent is 1 at 45 degrees, and that's really the only angle this happens at. At 30 degrees here, we have root 3 over 3, and our tangent values, it's root 3 up at a 60-degree angle. So when we say inverse tangent of -1, we're saying what angle between negative pi halves and pi halves this gives us a tangent value of -1. It would have to be down here, and we could see that this is a negative 45-degree angle. Or at least that would be the angle between negative 90 and positive 90 that gives us a tangent value of -1. So to answer this question, let's go ahead and fill this in here. We'd say this is negative 45 in degrees, or we could say negative pi fourths in radians. And so long story short, it's a whole bunch of asking what angle between these two angles here gave you this trig function value. So we'll expand on this in the next video. Cheers.